Okay, lesson 2. So I hope you've had a go at the starters. So first one, y is 3 to the power x, and we want to do 27 to the power of x. Well, 27 is 3 cubed, so that's just 3 to the power of 3x, so that's y cubed, because 3 to the x is y, so it's y cubed. Next one, 3 to the power 2x minus 1. Well, if there's a takeaway in the power, that means there was a divide. So it's 3 to the power 2x divided by 3 to the power 1. So it's 3 to the power 2x. Well, that's y squared. 3 to the power 1 is just 3. And the last one, 1 over 9x. Well, 1 over 9 is 3 to the minus 2. So that's 3 to the power of minus 2x. So that 3 to the x is y, so therefore it's y to the minus 2. Okay, second one. So we have a curve y equals 2 over x, and we want the normal when x equals 4. Well, straight away, get the y coordinates. So sub x equals 4 into there to get y is a half. So we also need the gradient. So to get gradient, we differentiate. So I need to rewrite that so I can differentiate it. So 2x minus 1. So differentiate it. So 2 times minus 1 is minus 2. Take away 1 to the power. So 2x minus 2. Sub in x is 4. So if you sub that into your calculator, minus 2 over 16. We get minus 1 over 8, I think. And since it's the normal, we have to do the negative reciprocal. So m is 8. So y minus y1 is mx minus x1. I'm going to times something by 2. So 2y minus 1 is 16, x minus 4. Expand 2y minus 1, 16x minus 64. Take everything to one side. So 16x, take away 2y, minus 63 is 0. Okay. Third one. We have 2 to the x equals e to the x plus 1. So there's lots of ways of doing this. I could do ln's of both sides, but I think the way I'm going to explain it is I'm going to change the 2. So I'm going to write 2 to the x is e to the x ln2, using the rule that a to the x is e x ln a equals e to the x plus 1. Now I can do ln of both sides and cancel out the e's. So I get x ln2 is x at 1. So get all the x's on one side. So x ln2 minus x is 1. Factorize out the x. So ln2 minus 1 is 1. Then just divide by it. And now I prefer the minus 1 at the front. So minus 1 add ln2. Remember, I like ln's at the end. Okay. Fourth one. We have un plus 1 is 2un minus 1. And we're told that u1 is 2. And we want to work out the sum from r is 1 to 4 of ur. So that means we want u1, so when r is 1, when r is 2, when r is 3, and when r is 4. So we need to work out the first 4 terms of the sequence. So we got u1 is 2. So to get u2, I'm going to use the rule. So it's 2 times u1 minus 1. So that's 2 times 2 minus 1. So that's 3. To get u3, do the same thing. It's 2 times u2 minus 1. So it's 2 times 3 minus 1. So that's 5. And to get u4, it's 2 times u3. So it's 2 times 5 minus 1. So that's 9. So the sum is U1 is 2, U2 is 3, U3 is 5, U4 is 9. So add them up and we should hopefully just get 19. And last one, pulleys 1. So we've got 2 particles hanging over a pulley. We've got air, which is mass 3 kilograms, and B, which is mass 5 kilograms. The string smooth, so it's the tension pulling it up, pulling the pulley down, pulling it up, pulling the pulley down. So my 4 tensions, you've got the weights, so 3G and 5G. 5's heavier, so therefore acceleration is going to go this way, and it's going to go that way for air. So we're going to get our 2 equations now. So for air, A is going up, so it's T minus 3G is M times A. And for B, it's going down, so it's 5G first. So 5G, take away T, is M A. So it's just 2 simultaneous equations now, so solve them how you like, but the easiest way, I think, or the quickest way rather, is just add them together, because when you add them, the T and the minus T cancel out. So I'm left with 5G minus 3G, so that gives me 2G. 3A and 5A is 8A. So then just divide by 8. So A is a quarter G, or type in your calculator if you want it as a number, and 2.5 meters per second squared.